joining this talk today. This is the first talk in the series that we will be having at the Cyprus Institute, presenting the European project EuroCC. This series is to let you know of high-performance computing developments in Europe, but also in Cyprus. I will introduce the project to you and the activities, and then we will have a follow-up talk that goes into more details regarding computational infrastructure, both at the Cyprus Institute, but also at the European level. So let me first start with a brief introduction of the Computation-Based Science and Technology Research Center, the acronym of which is CaSToRC. CaSToRC is one of the 4 research centers of the Cyprus Institute. It has been created about 10 years ago with the mission to promote and advance computation-based research and education, as well as provide computational resources and know-how to the user communities in Cyprus. So it has a dual role, both to do research and education, but also to provide services to the whole of the Cypriot researchers. Now, CaSToRC has been designated by the government of Cyprus as the High Performance Computing National Competence Center, for short NCC. Within this project that we will talk about EuroCC. And the purpose of this project is to cultivate the use of high-performance computing, simulation and data science, and serve the needs for compute and data-intensive applications for academia, government, and industry. So these 3 user communities are very crucial. So let us see what is this European initiative, which is called HPC joint undertaking. This is a pan-European action for HPC that will promote scientific research and innovation. And on the map, you see in color the countries that are currently participating in this action. You see most of the EU member states, but also associate countries, and also countries that are not part of the European Union, like Switzerland, for example. So 33 countries are joining efforts here to create a truly European computational network, which will be open to all researchers from these countries. So the EuroCC will provide funding, of course, for the creation of the pan-European network of supercomputers, and we will talk about it more later, and the following speaker will really spend a lot of time informing you about this. It will include in one of its activities the development of innovative exascale supercomputing technologies, because Europe wants to be independent in developing its own processor in order to reach the highest level of computation, which for the foreseeable future, it will be exascale. So exascale supercomputing technologies is one of the activities of this action. But in addition to hardware, it will support the development of software, and it will provide training for the researchers so that they will be able to use effectively these computational resources. So the budget foreseen in the forthcoming program of the European Commission is 8 billion euros for these activities, these three activities. Cyprus, as you can see, has signed as a member HPC, and therefore is participating in all of these activities. Okay, so let's see some of the, in brief, very brief, some of the main activities that EuroCC is already funding. I have to say this is, it's an action that is being co-funded by the European Commission and by member countries. So this is the basic idea of this action. You put the same money and you get from the European Commission an equal amount. The first action that has taken place was the assignment to 5 countries, 5 petaflop machines, and you see the countries in black here. They will be in Bulgaria, the Czech Republic, Luxembourg, Slovenia, and Portugal. Luxembourg is a very little dot you see. If you see my pointer, it's here. So this will be on the petaflop scale, while it has already approved 3 pre-exascale machines, which will be in the hundreds of petaflops, that will be hosted by Finland, Spain, and Italy. These machines now are under procurement, and they will go into operation probably next year. So I have to say again that Cypriot researchers will be able to access these machines through our participation into EuroHPC. Now, the other component that I mentioned that is being funded currently by the action is the development of European technology for enabling 2 exascale machines. We don't know the hosting countries yet. Probably it's going to be France and Germany. And the idea is that one of the 2 should be based on European technology regarding the hardware. So these are the 2 actions that are currently being funded. And the third action, which is the one I'm going to focus on today, is what the project called EuroCC. And this concerns the third pillar of the EuroHPC joint undertaking, which is enhancing the usage of HPC by academia and industry. And the European Commission, to facilitate that, has decided to co-fund a national competence center in each of these 33 countries that you see. So as I said, now you see the context, CaSToRC is undertaking this role of being the national competence center for Cyprus. And this is why we have created this series in order to engage with the researchers that need HPC in Cyprus. So what are the activities of the EuroCC project itself? So as I said, EuroCC will establish a national competence center for each country. HLRS, the computational center in Germany, will coordinate these activities among all the 33 countries. And as I already mentioned, CaSToRC is acting as a national competence center for Cyprus. The activities will depend on each competence center because each country has different needs. And this was also the idea why each country should have one. But basically, the underlying concept will be the same, namely, the target will be, of course, the local user communities in each country to offer support and services with the goal to advance scientific excellence, innovation, improve government efficiency, and raise awareness in society. So these are the underlying goals that all the centers will promote, each one, of course, depending on its needs, on the needs of the country. So this is a summary of what our National Competence Center will do. And you see there are 6 main pillars. The first one is to raise awareness of the potential of HPC. And this we are starting to do with a series of seminars that we will be holding probably twice a month. We will let you know the coming seminars, but also with interactions within our personnel being hired at the EuroCC. We have devised a training program based on a questionnaire that we send out to a lot of our users, to the researchers that use computational resources. These would be courses on HPC, structured courses on HPC, hackathons, and also hands-on training for developing of the appropriate software. The third pillar that this competence center will offer, CaSToRC, will be access to our production machine at the Cyprus Institute, where researchers can have access to computational resources and services. Together with that, we will provide consultancy for technology transfer and business development for the industrial sector of our users. The fifth pillar would be to come together with other groups at universities and research institutions, but also industry, to design co-development projects where researchers come together with our people here at the center in order to develop their code for these big scale machines. And the final and the sixth pillar will be specialized personnel with the high level knowledge of the various computer architectures that will help researchers to scale their software and compete for access to, in the long run, exascale resources on the European level, because this will be a competitive process, and our researchers in Cyprus have to be able to compete with their counterparts in other countries in Europe. And again, of course, this is towards enhancing research and innovation in Europe. Okay, so just to a brief summary of the key people that are undertaking this task that I mentioned on my previous slide. We hired three key researchers, Jakob Fingerad, who will lead the advanced user support for academic groups, Kyriakos Hatzigiannakou, who will lead the industrial and governmental user support, and Christos Christodoulou, who will facilitate our interactions with industry. So please contact these people. Here is a website where you can find more information. We will be very happy to come into contact with you and discuss how to facilitate access to HPC resources for your applications. Thank you very much. If there are any questions, any short questions, I can take them now before I give the stage for the next speaker. It seems that there are no questions. So Simone, please. Simone is one of our key people that we hire under EuroCC. He will explain to you the landscape in Europe. Thank you for your attention.
I'm very sorry. Now I think it's better, right? Okay. As I said, thank you, Professor Alexandru, for this introduction. I'm Simone, and today I have the pleasure to present an overview of HPC systems. HPC, which stands for High Performance Computing, is a tool used in academic research and industrial application for performing computation-intensive calculations. These tools, HPC makes use of supercomputers, which are very big machines. And in this talk, we will focus on the supercomputers available in Europe. We will review the latest release of the top 500 list. We will analyze the trends of the new architectures and thus compare CPU and GPU's architectures. And we will conclude with our mission at the National Competence Centers for HPC. The key component of a supercomputer is it's a computing node. So you can see here on the left a computing node from a supercomputer and the right a desktop. These two have similar components. We have everybody is familiar with a desktop. In a desktop, we have a CPU, a GPU, and some volatile memory, the DDRs. These same components are can be found in a computing node just multiplied by some factor. For instance, here on the left, we have 2 CPUs, 4 times more memory, and 3 GPUs. In average, a computing node is then 5 times faster, 5 times more performant than a desktop. We notice that here on the left, we will on the computing
Okay. Okay. So let's try again. Okay. I was discussing the features of a computing node and comparing it to a desktop computer. The conclusion of this slide was that we have on a computing node much more computing power than a standard desktop computer, and this is almost 5 times faster than the latter. In a supercomputer, we have many of these computing nodes. These are available, these are disposed in a rack, and many of these racks make a supercomputer. Additionally, all these computing nodes are connected to each other through a network. We have a centralized storage for the data. We have a centralized power supply and also the cooling of this system. So supercomputers are very big machines with heavy computing power. And there are many of these machines available in Europe. Here from left to right, we have in Spain, in Barcelona, the Mare Nostrum supercomputer. In France, we have the Juliot Curie machine. In Switzerland, we have PISDENT. Many other machines in Germany, like at Jülich, the Jules machine, at JRS in Stuttgart, Oak machine, and in Munich, the SuperMUC machine. Also in Italy, we have there is a Cineca, the Marconi supercomputer. In this slide, we see the largest machine in Europe, which are named Tier 0. And many other smaller machines are available. Those are named Tier 1. And also in Cyprus, we have a CaSToRC, one of these machines. If one is interested in looking at the largest supercomputer in a worldwide scale, we have one should look at the top 500 list. This list, which is which collects the 500 largest systems in the world, is released twice per year since 1993. On this figure, we can see how the machines are scored by performance. The performance is measured in flops, where the flops are the number of floating point operations per second that this machine can do. We start from 1 gigaflop. We start from 1 gigaflop, then we go from 1 teraflop. We go to 1 teraflop, which is 1,000 times 1 gigaflop, and so on with the petaflop and the hexaflop. Just as a comparison, a standard computer can does 50 gigaflop with a CPU and almost 1 teraflop with a GPU. So nowadays, a standard computer is almost as fast as the largest machine was available in 1993, and it is almost as fast as all the 500 machines put together. Indeed, in this figure, we see per every line, the top line is the sum over all the 500 machines. The second line is the performance of the first one, and the last line is the performance of the number 500. The performance over the year is increasing exponentially. We are following what is named the Moore's law, which states that every 2 years the performance almost doubles. The Moore's law has been satisfied up to almost 2013. Then, due to some limitation in the construction of the hardware, nowadays we are proceeding with a lower slope, but still exponential scale. And we can see that the largest machine nowadays, it's half hexaflop. And this is a machine in Japan, and these are listed here, so that in this slide we have the top 5 machines, and in this table we can see the name, the specifications, the country that is hosting the machine, the number of cores it can provide, the peak performance in petaflops, and the power of the machine, the power the machine consumes. So in the top 5, the largest one is in Japan. Then we have 3 machines in the US and 1 in China. When we go to Europe, we have the top machine is in Germany, in Jülich. We have 2 machines in Italy and 1 in Switzerland. We can see that the performance of the machine in Europe is 1/10 of the performance of the top machine worldwide. We notice in something important to notice in this slide is that almost all the machines are equipped with GPUs. These are NVIDIA GPUs, and they come together with a CPU that which brand can change. So we have IBM, AMD, or Intel. This is a common practice in supercomputers, having in a node both CPUs and GPUs. And the advantage is that one can gain much more computing power with a smaller amount of nodes. So we have here, as a comparison, we can compare the Sierra with Sunway, and we can see that we get the same performance with 1/10 of the number of computing nodes. In this slide, we report the trends over the years of the vendors of the hardware. We have on the left the vendors for CPUs. In this case, Intel is dominating the market. And on the right, we have the vendors for coprocessor, which can be GPUs or other kind of devices. And in this case, the leader is NVIDIA with its GPUs, and it's dominating most of the market. This is important to notice because we are going to see next that this will slightly change in the future. As Professor Alexander introduced, we have the project EuroHPC will bring new systems in Europe. We are most interested in the 3 exascale system that will come up in the following year. Additionally, we will have 2 exascale systems coming in within 2023. The 3 exascale systems are listed here. One will be in Finland, another in Italy, and another in Spain. And the Lumi, the system will be available in Finland, will have a performance of 1 exaflop. So we'll have a larger performance than the system that is top nowadays. Though the computing power evolves fast, and so when Lumi will be available, most probably also the machine in the US will be available Frontier, which will already have 1,500 petaflops. So this is already exascale. Exascale size systems are expected in Europe for 2023. As I said, something important that will come up in the next years is that we will have new brands of GPUs. In this case, we have AMD and Intel that also have been able to win the tenders for the largest systems. And so the future system in the US will not be equipped with NVIDIA GPUs, but with AMD and Intel. So now we will compare the major difference between a CPU and a GPU. This is important because one needs to know how to use the hardware that is available. So on the left, we have CPUs that everybody knows they are equipped, every computer has. And on the right, we have GPUs that mostly are used nowadays in gaming computers, so are very powerful devices. A CPU is optimized for low latency. This means that it's a system that has a very big cache. The cache is a memory that has very fast, very high bandwidth, so the cores can access very fast data from it. The CPU has few computing logic, and it has a complex control system. On the other hand, the GPU has many cores, smaller cache per core, and it has dedicated RAM. So while on the left, the RAM is then provided addition to the system, the GPU have dedicated RAM that is installed directly in the device. And in this case, this is the core of the GPU, and all these slots here are the RAM available. So these are closely connected to the device. So the GPU is optimized instead for data parallel throughput. What does it mean? It means that the CPU is usually dedicated for heavy-duty operations, for operations that are can manage with randomized access or very complex operations. On the other hand, the GPU is optimized for high throughput, where the data is processed in parallel, and very big, very large amount of data can be processed in once. The newer GPU, the modern CPUs are coming have more parallelism, so they are becoming like more GPU-like, and the newer GPUs instead have better control logic, and they're becoming more CPU-like, showing that the best architecture is somewhere in the middle between these two devices. They are both important because a standard computer would not be able to work with only GPU, since it needs to do complex operations as well, while the GPUs are fundamental nowadays for doing big data calculations. But why is the architecture so important for us? The architecture is so important in HPC software because it affects its design. So a standard workflow for a software developer is to produce a software in a given programming language. Then a compiler will take care to convert this programming language in machine code, and the hardware we run this machine code and produce results. So usually one should not worry about the architecture, just the compiler, if it supports such architecture, will produce the suitable machine code for the device. On the other hand, we want to do HPC, which means high performance. So we want to have optimized machine code for the architecture. And this will also change how we write our software. So this is a very important feature for us. This is because we need to know, for instance, what is the memory bandwidth of the architecture we use, what is the cache memory size, how many operations can do per clock, how many cores we have available, etc., etc. So these are all features that will affect how we construct our high-performance software. So doing research in HPC is a quite sophisticated approach, where one starts with a scientific problem that has a numerical solution. This scientific problem must be computationally intensive and must be parallelizable, so both from task and data point of view. Then one requires a software that is optimized for HPC. This software must be also scalable, which means that increasing the computing resources, the computing time will decrease. Then one will need access to a supercomputer. This so far can be done through Praise calls, which all these machines I mentioned before are available through Praise, which is the European project. And to Praise, one can ask a preparatory access to a system that where then one can test the software and benchmark it. Though these preparatory access are very small in computing time, and for having access to the full capacity of the system, then one needs to write a competitive proposal for computing time. These proposals are then judged from both the scientific and the computational aspects. Once one has access to one of these systems, then the production of the results starts. This usually takes about 1 year, produce a huge amount of data, and then one is ready for publications. So this is all the workflow we follow when we are doing research using HPC. Additionally, one has in mind other kind of development. For instance, one can do algorithmic research, numerical improvements to the approach, to the numerical approach to solve the scientific problem. One always needs to be aware of the possible software developments can be carried out because the architecture is always evolving. One needs to have an eye to the new methodology that come out. And also machine learning is a new plays an important role nowadays because it has shown that it has a very large application in many problems and can help in both data analysis, but also in the way we do calculations. Our mission then at the National Competence Center is to provide support in Cyprus for all these workflow that I just described. And so our staff has years of experience in HPC. We have all run on the largest machines available in Europe and the US. We do software development and we do cutting edge research since 10 years at least. And we have experience in numerical algorithms and large scale simulations and also in data analysis and machine learning. So all this know-how that we have developed in the years, we want now to transmit it to the other community, scientific community that wants to do research in HPC. And we will do this through trainings, seminars, and events, and also direct consulting to the project. Our targets is academic research, industrial application, and governmental support. We did a survey in Cyprus, and in Cyprus we have a very interesting community that does research in HPC. It does research in all the fields and we in a very distributed manner. So we are looking forward to collaborate with everybody. And we will do this by starting with, we already defined the training program. This will have events on all the levels. We will start with a beginner event, then followed by intermediate, an hackathon, where for a full week we will sit with different groups to work on their projects. We will have a session of training for industry and advanced event. Additionally, over the full year, we will have an internship program that which is paid and can go up to 6 months. At start, we will have the first event that I advertise here will be the beginner events, which will be 3 days long. We will do an introduction to HPC, an hands-on on our system, and other important features that someone should know when he wants to do HPC. About our system, we have here in this slide are summarized the features of them. The current system in action is Cyclone. In the past, with Cytera, where many people may have run from 2012. Now Cyclone is a larger system with a better performance against Cytera. It's equipped with the latest NVIDIA GPUs and is available for the projects by access to our website. We have also some prototype systems, and in the upcoming year, in the next year, we will have a new system dedicated for industrial applications. So this was my talk, and I want to thank you for your attention. And we are still recruiting people for our group, and we are looking forward to have interns and postgraduate students. So if you have any question, please ask now.
Simone, I have a question and probably a comment just to start off the discussion. Cyclone is the production machine, and as a production machine, of course, will be open to all users from Cyprus. Maybe you can say a few words about, the process, although the next speaker in this series, which is going to be Stelios Rodogridou, will elaborate more how to get access to this machine. But maybe you can already say that it will be open and say what we can provide to the users.
Sure. Yes, the Cyclone is open for access now at the moment for preparatory access, and we can, from our side, we can provide support for running on the system, and also interesting point is these machines. It's a very interesting machine because can be can provide a baseline for then accessing the larger machine in Europe, since it is equipped with the most recent GPUs that are then available in other systems. So an important step to do before going to larger system is to port a code that maybe is only running on CPUs to GPUs. And this is something we can provide support on.
Thanks, Simone. So I believe now your microphones can be unmuted. So if anybody would like to ask a question, please go ahead. No questions? Okay, then I would like to thank Simone. And as I said, we will try to have a talk every other week. And the next speaker will be Stelios Rodogridou, who will explain the process for accessing Cyclone. Thank you very much for joining us today. Hope to see you at our next event. Bye-bye.